Okay, welcome everybody to the RTOP for the first RTOP of the year, 2025. Everybody had a good holiday and Christmas and New Year's, and we're off to the races this year. Let's see some announcements. The emails, we just updated the email list so that right now we have 489 members paid for 2025. That's lifetime members, honorary, etc., plus paid 2025 members. We had the original database up to December 31st. It was 700 something. So theoretically, we lost a couple hundred people, but those people were not responding to 3 or 4 email requests to update their membership all the way from 2023 up to 2024. They still can update their memberships, but right now, the database we have now are really up to date, fully paid members, and those are the ones that get the email and the notices, and that's the benefit of being a member for this. Let's see. Obviously we're going to have the March Western Conference at the VLA, the June, July Eastern Conference at Green Bank. Those are still on. And I think what else? And let's see. While I've got you on, Johnny Cox had questions about the Eastern Conference. I got Jay Wilson on, who was the Eastern Conference coordinator. So maybe you could answer some of those. Go ahead, Johnny.
Oh, thank you. These are very simple. When do you think we can sign up? I've got an angle on some accommodations that are pretty close, and I want to nail those down. And I just want to make sure before I nail them down, because I don't think I can get my money back.
Oh, I see. I think, and this is unguaranteed, I think that the dates are nailed down with Green Bank right now. And let me go double check that before you go do that, but let me put that out. And so I think that we've got those, we got the VLA nailed down and we got the Green Bank dates nailed down already. So I think, let me put that out in a notice. I'll try to do it this week, what the dates are, the exact dates, and I'm pretty sure they'll stay that way.
Right.
I think Marcus Fisher, who's our new VP, got them organized. It's just a question of us putting that out in the notice.
So
yeah, go ahead.
I was just going to say, so I should wait on you to let us.
Yeah. And if you don't see anything this week, bug me. But I'm going to try to get with Marcus and verify that that we're 100% on those.
Okay.
And bug me, just email me or do whatever.
Well, I'll be discreet.
You guys don't have to be discreet with me. Just go.
I'll try to be civilized. How about that?
Yeah. Okay. I'll take that.
I've got just one other quickie. I've got a dual dipole antenna. I call it my traveling one, that I took to Texas and New Mexico for the eclipse. And I heard that I could bring that along and set it up. Is that?
Oh, absolutely. Everybody brings their pet. If you can get it there, you can set it up. We got a big area in the back, and you can set up. People set up their stuff every night.
What about power?
We got, they usually, we get an extension cord out there to power all the experiments.
Me and a friend of mine are driving, so that makes it a lot easier, but I've flown with this thing and I'm so glad I don't have to do that anymore.
Yeah. No kidding.
But I can bring power cords, so I will do that. Let's see.
Yeah. Just a long extension cord. I'm pretty sure we're going to have one ourselves. Gets it out to the area, and then we can branch off from there for power.
All right. I think that's all I got, and I'll be listening for you before I kick it in gear here.
All right. All right.
Thank you. Appreciate it.
Okay. Let's see. Got a little bit of a lineup here. Let's go with Wolfgang. We're going to get the European and Asian guys first.
Yeah, hello. Just a quick comment on the upcoming conferences. I think it would be a good idea if we would update our website, because if you go there and look for conferences, that's still the 24 ones showing up. If maybe if somebody gets a chance to update, that would be great. Okay, coming to the technical side of things, there's not really much I can tell at the moment, with the exception that we do have at the moment, we do have an issue with our front end on our 25-meter dish. Not sure what exactly it is, so we're trying to figure it out. So at the moment we're down on our 25-meter dish. And I took the opportunity to do a little bit of experiments with the small antennas, and I had received a Patchiagi antenna from Alex, who designed that. You probably, or most of us, will know that one. I didn't get a chance to really look at it for quite some time, but in the last couple of days I did that. So maybe I just quickly show those results, if that's fine with you. Let me share that. Okay. Can you see my screen, I hope?
Yep.
Okay. What I did is I was just setting the antenna up, looking straight up. So that means that we're looking from my side at a declination of around 50 some degrees, and let it pass. The first slide I'm showing is just an example of the hydrogen spectrum, somewhere close to the galactic plane. So it's getting quite a good signal to noise ratio with 5 minutes integration time. And what I then did was let it sit for 24 hours to get a full sky transit. And the result of that full sky transit is this one. So you see the galactic plane passing through the beam twice. Essentially, let me explain that a bit. The vertical scale is the velocity. Blue shifted is up, red shifted is down. And then it is 24 hours of in right ascension here. And the color grading is essentially the intensity or the brightness temperature. So you see the essentially the galactic plane passing twice. There's a little bit of a gain jump here in this area. We had some snow, and I think that's possibly the reason for that, but I'm not sure about it. One other comment is all this data is VLSR corrected, so it's corrected for the local standard of rest. There is a spurious line here, which you can see. That's an interference, which is actually at a constant frequency, but as we're doing the VLSR correction, it just shows in the velocity frame a variation. So it nicely shows how the correction goes over the 24 hours. One has to say, though, when you have a wide beam, like with this antenna, obviously the VLSR correction is only valid for the foresight direction of the antenna, and things coming from the side will have a slightly different VLSR correction. That is something that you simply cannot account for, but at least it gives you some indication on how the correction should go. Yeah, I guess that's all I wanted to show. Essentially, the message here is it's a fairly simple antenna. It's a Patchiagi, which I believe has 13 directors and the radiator and the M1 reflector. It's giving you a nice signal. No problem at all seeing the hydrogen spectrum with that. And just to finish things off, let me go to another computer and share the screen there. Let's see. I want to share the full screen. Okay, what is showing up here? Here is again the spectrum from the same antenna, and that is what we are receiving right now. So let me just update that. It's a 5-minute integration time. So you may have seen there was a small change. Where at the moment we are at the right ascension, 2 hours, 35 minutes, which is before the transit. So the signal to noise ratio is less. So just the signal is lower. And I keep recording that the intention finally is to make a comparison between this antenna and a few other antennas, some other patriarchy antennas, which we have, a smaller one and a much bigger one. And eventually I will be able to tell a bit more about that once I've done taken all the data. I guess that's all I have for today. If there are any questions, I'm happy to answer those.
Looks good, Wolfgang. Thanks.
Yeah, thank you. Also, I was curious about on your bigger dish when you need to work on it. How do you get to the feed on it? Does it tilt over far enough, or do you have a platform?
Yeah, that's really the thing that's prevented us so far exactly identifying what the issue is. We have to go up and we have to get the receiver box down. And actually the plan is that next Sunday, we will have a meeting and discuss things because we need to have the right people who can climb up and then get the receiver box down. So it's probably going to take us a few weeks before we get things fixed.
And how is the weather in your area lately?
Yeah, that's another part that plays into that. At the moment, we had some snow. It's getting warmer right now. The main concern is that we don't have wind, that we don't have rain. So that, of course, no ice. We need to be comfortable and safe to climb up. And that will essentially determine the timing. So next Sunday, we'll discuss who is available to climb up. Not everybody likes to do that. And I myself, I don't go up there. I'm too old for that. So we need some of the younger guys and some experienced guys who can climb up and then get the prime focus part down. Yeah, it's something that we really avoid to do. But in this time, it's clear that the issue is with the prime focus part of the front end. And we just have to go after it and do it. We can only hope we can do it reasonably quickly because we really want to continue our observations, but we have to be very careful about safety doing that.
Yeah, you have to go up and get it and bring it down and then work on it. Then you have to go back up there and put it back. So you got 2 trips up the dish.
Yeah, that's right. Typically, experience shows getting the thing down is a 6 hours exercise for a couple of people. And then, we have to work on it, do all the careful measurements and tests and see, because we don't want to bring it up and then find we have the same issue again. So, those are the things that come with a large dish. It's not something we can easily do things. Also, part of the discussion that we'll be having is maybe we should plan for designing a next generation front end, which hopefully would then also be easier to install and get down again. But that's subject to next weekend's discussion.
Okay. Thank you.
All right, any more questions for Wolfgang? All right, Dmitry.
Well, hello to for all. Happy New Year for everybody. In December, just a short message. In December, I continued observations of W75N WØAIR 6.7 GHz because it shows some variability. This is star formation regions W75N and BR21, very close to very close each other to two regions. One of them, the DR21, is brighter in infrared, but in methanol luminosity is W75N is much brighter. This is still some puzzle, at least for me. I don't, I can explain it for now. One moment in my previous presentations and even in two papers in journal, there was mistaken beam filling factor. Mine here is forgotten, was forgotten, but in calculation all is okay, and in calculation this might is accounted. The minimal detectable flux, peak flux density for my setup is about 80 Yansky, and DR21 is under the thresholds of detections. So I can see only W75N with my setup. In November, this was quite a spectrum of W75N. Similar spectrum, first half of November, but in second half of November, some perturbations I have seen. Line 7.5 kilometer per second disappeared for a while in the mid of November. At the end of November, this line 7.5 began to restore, and some lines about 10, group of lines about 10 kilometer per second appeared in November. In December, line was about 7.5 kilometer per second is restoring. Line about 10 kilometer per second was fading, and rest to observations at the end of December shows 7.5 line was restored. For lines about 4 kilometer per second, somewhat became somewhat narrow, and even fading at the end of December. This measure, as I can see, shows interesting variability. It's possible. I have desired to continue these observations at least in January to see how it will change. That's all for now. With some questions, I will get those once.
Any questions for Dmitry? All right. Thanks. Great stuff.
Thank you.
Okay. I've got a second Wolfgang on here. Is that?
That was me with my second computer, so I could show the live picture.
Oh, good.
And I just connected that in the meantime, so don't worry about that.
Great. No problem. I just, let's see. Let's go to Andrew.
Hi, everybody. Nice to see you this evening. We've also got a little bit of snow here as well. I doubt as much as Wolfgang's getting because we seem to get a bit less of it being closer to the North Sea. But still, it's quite nice to take some pictures of all the radioscopes in the snow They can go on a few presentations in the future. I have today, before this started, just finished my 4th set of 2 lectures for the Astronomical Society of Penang. There does seem to be an increasing interest in people learning about radio astronomy, which is brilliant. And I'm in the process of or just being commissioned to give a talk at the International Astronomy Show in Coventry later in the year. I spoke there last year. So I've just sent him a list of possible talks that I've prepared, and he can choose which one he wants. So I can recommend to people that don't do it that you offer to local societies and things and say that you can give talks, because you'll find there's probably a bigger interest for it than you might expect. Now, so in terms of what I'd like to talk about, first thing, I'm going to talk about something which many of you I know will do, but we never seem to talk about in this group. I notice we've got at least one new person starting today. Let's bring this up. I'm just going to share. So hopefully you can see this RMOB. Wolfgang probably knows about RMOB. A radio Meteor observation bulletin, I think. So these are just my observations for the first few days in January, showing that according to my kit, the peak of the quadrantid meteor shower was at about 10 o'clock on the 3rd of January. So, if you haven't done much radio astronomy before, setting a kit up to actually be able to detect meteors is a very or relatively simple and easy way to get started, and gives you some quite fun results. If I pull that out a bit and we change over to there, can you see my Spectrum Lab thing appearing? Or is it not changed screen?
You did. You got it.
You did it right. Okay. So this is an example of a piece of software called Spectrum Lab, which allows you to show in the moment no meteors coming through, to show the meteors coming through in the 3D plots, or you can change it to, if you want to a 2D so-called waterfall plot like that. And some people prefer that the way around. I quite like the 3D one because it's quite spectacular. I just mentioned that if anybody's interested in finding out more, please let me know, and I can tell you how to get started and the sort of equipment you need, which is not a great deal. Anyway, so that's the first thing I wanted to mention. Just when I come back, I'll stop sharing that. Oh, perhaps for those, one thing extra thing I'll do with that. Sorry, bear with me. We'll just go back to that screen. Pull up my data file. Just show some examples of what these things look like when they come through. So there we are. So there's an example of a meteor that's coming through, showing in 3D. And you will note when they come through, they all come through on the same frequency line, because it's being picked up from basically picking a signal up that's over the curve of the Earth. Normally you can't pick it up, but every so often it hits a meteor and bounces back down, and you can pick it up and it reflects off. So they call it meteor radio scatter. Anyway, there we are. That's that. I'll get rid of that now. So that's, sorry? Did somebody say?
I apologize for interjecting. This is Tom Fulton. That is very much of interest to me, and would love to learn more about your setup at some point.
Yeah, I'll be very happy to speak to you about that. We could set up a Teams meeting or something and have a chat, or a Zoom meeting. Probably so that I don't put my email into the open on here. If you contact Rich, he can give you my email address, and he can get in contact. Be very happy to talk more about that.
Thank you very much.
And show you more, get you more motivated with it.
Oh, I'm motivated. Thank you.
So the other thing I wanted to talk about is, I don't know, I know most people here do follow the mailing list chats, and I'm very much appreciative of all the advice that people give, whether it's Wolfgang or Alex or anybody else here, Ted, and very many of you. So firstly, to say thank you very much to you all for that. All my rather silly questions I keep asking. But there is something that I thought we've been talking about recently and might be very helpful to actually discuss in this forum so that it's actually here on the video for anybody else that wants to access it in the future. And that's this question of the benefits or otherwise of changing your coaxial cable. And more recently, in association with that, the location of the LNA. So just to explain a bit of background. Firstly, I was having a chat with Alex about this, and we noted, or he noted, that I was using RG58. And at that particular time, I had a 5-meter run of RG58 from my solar cooker radio telescope to the box, and I had the LNA in the box. So this signal was going through 5 meters of RG58 before it actually hit the LNA, and he was able to show me the calculations that this led to a significant reduction in the strength of the signal. I've gone out and bought some KMR 400. I've got to say, I'd never even heard of KMR or LMR 400 or 240 before this point. So I do know about it now. He's not reading about it. And as you might expect, changing RG58, which has quite a high attenuation figure in decibels, to LMR or KMR 400 did make quite a significant difference to the strength of the signal. Not a surprise, perhaps. The next question that arose from what I've been discussing a bit online was what type of cable is the most efficient to get? So maybe we can have that discussion here, as I say, to put online. But then the second question that went alongside that I noticed has been coming out today is, if you put your LNA where you're supposed to put it, next to the dish rather than doing what I'm doing and having it next to the receiver, which I'm naughty and should now change, which I'm going to do next. Then if you get enough amplification at the dish, then perhaps changing the cable or changing it to such an expensive cable isn't really worth it, and you can get away with something significantly cheaper. So over to you guys. I'm not an expert on this. I just wondered if people would be happy to just talk through their thoughts on that, and whether we could come to some conclusions to help people to, like me, trying to set up their own systems.
I'll give you my 2 cents on that, if I may. The standard policy is that you put the LNA as close to the antenna as possible. There is a baseline noise of the system, and it's electronics or whatever. Any cable that you add in there attenuates the signal. It does not attenuate the noise. The noise level of the system is based on the thermal noise of the system. And so any cable, I don't care if you use foot diameter cable, between the antenna and the first gain stage, it is going to attenuate the signal. I use more expensive LNA. It has about a 0.3 dB noise factor. The standard Sawbirds have 0.8. Any length of cable will reduce the efficiency. And unless there is an extremely good reason to do that, you're losing signal. So it's not even a matter of choice. It's not a matter of what kind of cable. It's that it's not the right way to do it. You put the LNA at the noise, at the antenna source. Then once the signal is amplified, the signal and the noise level is amplified above the noise threshold of the electronics. Once you hit 20 dB, you can use your RG58 again. It's just, like I said, you really need to look at the freeze equation to understand that. But putting any kind of cable it attenuates everything, and you cannot recover it out from that point on.
Well,
Yeah, I can only confirm that it's really the best idea is always to put the LNA as close as possible with as few attenuation as possible between your antenna and the actual LNA. There's a transformation. Anything that's behind that, the noise, is transformed to the front end by the gain of the LNA. It really doesn't matter if there is a somewhat noisy thing behind it. The only exception, when you want to do something in between your antenna and the LNA is in the unfortunate situation when you have a very high level RFI background. In these cases, it may happen that your LNA gets overloaded and doing all sorts of funny things as a consequence. If you're in that unfortunate situation, then it may be needed to have a filter in between. That filter has to be as low attenuation as possible. Nowadays, this means it should be a cavity filter, which can be designed to have 0.2 dB loss. But these are really extreme situations. If you do encounter an RFI problem, overloading your LNA, the first thing to look at is your antenna itself, how much filtering that antenna may give you. If you have a very wideband antenna, then you get no protection from RFI. If you have a circular waveguide, a cantenna type of thing, that has a very good attenuation at lower frequencies. So that's something that's always worth considering. Is my feed or my antenna itself narrow band enough to suppress RFI? That would be the first choice. And if then in those cases where you really can't avoid it, you need to put a filter in between. But as long as at all possible, the LNA has to be right at the antenna. That comes with a difficulty, of course, that your LNA has to be water protected. Has to withstand the environment, but it's worthwhile that effort. And probably that's much cheaper. So that's much cheaper. Sorry.
Yeah, so
Go ahead.
How would you recommend protecting it from water?
Well, the way we do it typically is if you take the frequently used, what's this called? From like the sawbird. The sawbird. What we do is put the sawbird in an aluminum cast housing with the sawbird does have an SMA connector at its end. What we do is to have an aluminum cast housing. On the outside, we always use end connectors. So it's a transition, a flange connector, which has N on the outside and SMA on the inside. That gives a little bit of attenuation, but that's the way we do it. I could send you a picture of how we do it. These are standard die-cast aluminum housings that we use for that purpose.
Oh, I see. I get the idea. So that basically you're sealing it inside an aluminium box, which has separate connectors, and then the stuff's all inside the box then.
Yep, that's correct. It's an IP65 enclosure by design. And then we take one of these flange connectors. If I get a chance, I can see whether I can find a picture while we're talking and see whether I can show that.
A question. A question.
Go ahead.
I saw on YouTube someone had stacked two LNAs in serially. Is there any validity doing that? And anyway, what does everyone think about that?
Eventually wind up saturating the second one. It's not required.
Okay.
It actually depends on the gain that your LNA has. We do have some cases where we do exactly the same. We have two LNA blocks in the housing with a 3 dB attenuator in between them to get them a bit decoupled. The reason for doing that in this case is that the gain of the individual LNA is fairly low, and we wanted to have enough gain so that we can actually benefit from that total gain in order to suppress any influence of the remaining chain as far as signal to noise is concerned. Ideally, just to put a number up, ideally we would be choosing something that has a 30 to 40 dB gain as the first LNA. And if you're using different components, you have maybe only 15 dB, then you can put two just right behind themselves. Just make sure that they don't tend to oscillate or have strange reflections. A small attenuator in between the two stages can be beneficial.
Do those LNAs transmit the power on through to the primary LNA?
That really depends on the design of the LNA. There's some, typically, if you have two in sequence, typically you would not have the power. If they're powered by the coax feed, they're typically not powering through the front and then again, so they can power up the next. So in those cases, when we use an LNA with two stages, we typically power them separately. It really depends on the device that you're using. But what many people use nowadays is the Sawbird that has enough gain. It actually is internally, it's a two-stage amplifier. It has two stages and it can be powered through the coax cable. So that's a very convenient device actually to use.
I should have preferenced my comment. My comment was based on using a pair of Sawbirds together, which would have given you 80 dB gain, which is not a good idea. Actually, on my 1.2 meter dish, I have two LNAs, but each one has a gain of around 20 dB and a cavity filter in between. So saying you're ganging or parallel or seriesing two LNAs, as Wolfgang says, is dependent on the gain of the system. And so the magic number is 30 to 40 dB. And we have to preference this also on, this is H-line. People are doing a lot of different things, and there may be different conditions and different measurements that require different setups. But typically, you would not put two Sawbirds together.
No, definitely not two Sawbirds. Just as an example, what I've shown just a couple of minutes ago, that was the setup there is, it's not a Sawbird. It's a separate different LNA where actually there are two stages because each one has only 15 dB. So we're getting 30 dB in LNA gain, which is directly at the antenna or relatively directly at the antenna. Then we have a couple of meters of cable, standard, it's a 7 millimeter cable type thing. Then there's a cavity filter, and then we have two additional gain stages just because we have a large distance between our outdoor environment and the indoor. So there's a lot of cable attenuation on that path, and we need to compensate for that. So we have another 40 dB, maybe not that much, maybe 30 dB of gain, because we're losing the 30 dB of gain again in the cable. It's a long cable run. And so that's the particular design that was used when we tested this antenna from Alex. But depending on your local situation, if you don't have a very long cable run between your outdoor experiments and your shop, then you can certainly work with less gain overall.
There was one other thing I wanted to say, Rich, which was just that the comment that was being made about sizes of dishes and the difficulty of using them. People will know that I have two hydrogen scopes that are working at the moment. One that works well, and although Alex would debate that, and one that at least it maps the Milky Way anyway, and one that's having difficulty getting set up. Which is one that's based on my ptarmigan array, and one that's based on this parabolic solar cooker dish. And the difference is the ptarmigan's at 86 centimeters by 86 centimeters, and the solar dish is 1.5 meters across. And every time I want to do anything to the solar dish, it's a right nuisance. I have to change the elevation and bring it down to get to it. And that's without all the hassles that Wolfgang's got. But whereas the smaller setup is so much easier to play around with and make changes. So anybody who's setting themselves up for the first time, I would recommend keep it small. Just like astrophotography, keep it small, keep it simple, and enjoy the process rather than trying to go over the top.
Great. I just posted the link to Radio Astronomy Formulas Lesson 14 noise figure, noise factor. How do you quantify everything that was just said here? Go look up the noise figure, noise factor of the components, put them in order, do those calculations, and that will give you the first cut at how it affects changing things around, putting the LNAs behind the cable or cable ahead of it does that. It's really dramatic, showing how the gain changes. Take a look at that. Now that's how you can do the math on it. Okay.
Rich, can I make a quick comment or two? There's been some talk recently about using right angle connectors at the beginning of between the antenna probe and the sawbird, for example, that you can have some pretty good losses in right angle connectors if you don't choose them very carefully. The other point is that television line amplifiers that can be bought off of, for example, Amazon or eBay are very inexpensive, cover the frequency properly. And if you want to, you can then go to very inexpensive cable, which is the RG6 television cable at 75 ohms. And you can eat the mismatch because you have the LNA at the beginning. And that will allow you to have a much longer run. And most of the television line amplifiers will pass DC bias or a DC voltage through. So if you choose that carefully, that line amplifier and so forth will give you inexpensive cable if you have to have, say, 100-foot run or something like that. Whereas this other cable is quite expensive, like LMR 400 or LMR 600, which is even better, but stiff as a poker. You don't really want to use it if you can avoid it. So I would think that can be done, and the line amplifier can be put, as Wolfgang says, you can use a small attenuator in there or an isolator if you can find one cheap somewhere to keep oscillations and so forth down.
All right.
And at the far end, where you come out of the 75 ohm into, say, your receiver, you can eat the small mismatch. It won't hurt anything to have that little mismatch in there.
Okay. All right. We're going to shift hemispheres here with Rob Lucas.
Good morning and Happy New Year to everybody. I see that everybody in the other hemisphere is putting up with snow and cold weather, but here I'm looking for a day at 37 degrees C, which is hot. So what have I been doing? I've been away for a long time and come back, and I've been away again for the holiday season. But what I've done is to put together Alex Pettit's patch antenna and struggled with that for a little bit and finally have it up and running, but I don't have any data to present. And the other is the scope in a box next to it, and the computer crashed on that. We're working on getting that back together. I went out to the observatory and got that almost ready to go. And I took my C-Star 50 up, and I'm learning how to do the framing operation. And that all seems to be working. And with luck, some data will come out of what's going on, and I'll be able to present it next meeting.
Wow,
So
great. Any eclipse trips planned?
I went to Patagonia for 9 days on a road trip. And that was not, I thought when I picked up the Amarok that that was a mistake because I was going to be driving on the main roads in Patagonia, only to discover that you go 200 meters, there's a sign that says end of the road, and you ended up with 9 days or hundreds of kilometers of gravel roads. And went through 2 mountain passes, and there were a blizzard in both of them. And anyway, when the annular eclipse occurred, it cleared up and it was absolutely brilliant. So I have a video with the Sea Star as well as a video with the Nikon P1000. Both are very good. And with luck, if you want, I'll show some pictures next month.
That'll be great. We always like to see those. All right. Thank you very much, Robert. Let's see, Edward.
Hello. I've only one small thing actually to share.
Explain to everybody where you're at, so some of the new people don't know where you're from.
Okay, sorry. Yeah, I'm Eduard. I'm from the Netherlands, and my main focus is actually on lasers, which, if you are not familiar with them, are essentially like the microwave equivalent of lasers. And interestingly, lasers occur naturally in outer space in some big places like in star-forming regions. So yeah, with that out of the way, I just want to show you a very short few slides on some recent observations. So yeah, these observations I'm mainly working still with the 1 meter dish at 22.2 gigahertz, which is the frequency of water masers online. So yeah, this is a small 1 meter dish telescope. It's placed on a HEQ5 mount, and yeah, I'm using a special LNB unit, a Norset 9000 LD LNB, to down convert the 22 gigahertz to something that my SDR can handle at 1.4 gigahertz. Yeah, what I've been mainly busy with in recent years actually is doing regular observations of the so-called water masers, which occur in star-forming regions, and they are very variable. They've been mainly focusing on a particular region known as W49, because W49 is just one of the strongest masers and also one of the strongest radio sources at these frequencies. And it's also very active, so it's quite interesting to follow it and see if there are any changes in the spectrum. Oh, back in November, I made a spectrum. Actually, I've been doing this for quite a while. What I normally do is that I only make a spectrum of the central cluster maser features at around minus 10 kilometers per second. And the reason for that is that the frequency range of my, or the frequency range of my SDR, it's an AirSpy unit, is about 6 megahertz. So that only covers about 50 kilometers per second in velocity space at these very high frequencies. So I can only detect certain portion of the spectrum at a time. So I've been mostly focusing on like the central part where all of these different peaks are at around minus 25 to plus 25 kilometers per second. However, what I did in November was, this was actually spurred by an observation by Wolfgang with their 10 meter dish at WØAIR. There are actually some features in this maser spectrum that occur at much greater red and blue shifts. In particular, there were some bright features at minus 70 to minus 60 kilometers per second, which I thought was quite interesting. So what I did was that I essentially recorded 4 spectra with a little bit of overlap in between at different centered at different frequencies to get a much wider spectrum of of the star forming region. And here you can indeed see in the November spectrum from 26th of November that there's a very, besides the main cluster at around 0 kilometers per second, there are these very bright peaks as well at minus 70 kilometers per second. And at December 27th, I did the same, although I only made 3 spectra, and the frequency spacing between them was a little bit too large, so there are some few small gaps between the spectra. But overall, it's quite interesting to see that now it seems that these very bright peaks at around minus 70 kilometers per second have now gone most. So there's fairly little change actually in the main cluster. Yeah, I don't know exactly what's going on here, but maybe this means that there was some sort of flaring event, maybe at this measure at the minus 70 kilometers per second feature, and that has now quieted down. What this all means, I don't know, but it's interesting, and I'll try to follow up on this later on with some more observations. So besides that, I also made a quick observation of Western 75 as well. This source was also shown by the way, this source was also observed by Dimitri at 6.7 gigahertz, as he has shown us. Yeah, not too much going on here. There's just seems to be just one simple peak at 10 kilometers per second, and that's basically what we've been seeing over recent years, except that it seems that the intensity of this peak is varying quite a bit, but it's very hard to say because I don't have any independent calibration to Jansky or anything. Could just be like some gain variations or pointing errors in my system as well. Okay, so that was all for today. Are there any questions?
Maybe just a little comment on the W49. I think the great variation between the two parts, we have to understand that when we talk about W49 and the water masers, this is actually not one water maser. It's different water masers in different parts of W49, and they're pretty much independent. So they're separated somewhere in the cloud, and they don't interact with each other. So each of those has its own life. And while we can see some variation in one part, there's no variation or little variation in the other. So it doesn't really be of much a surprise. We do understand that water masers are very variable, and maybe it's what essentially tells us, yes, it's at a different velocity, which is a clear indication that that's a different part of the W49 cloud, and the difference in variation supports that idea. I guess that's the only conclusion I can draw for that, but in any case, it's interesting just observing that.
Yeah, thank you for your comments. Yeah, it's probably better to describe these things as clusters of individual maser spots rather than just call it a maser. Maybe that's a more correct terminology. But yeah, I was just surprised that the short time scales of variation, like 1 month you see this very bright peak, and next month it seems to be mostly gone. That's quite interesting.
Can you tell me what your integration time is typically today?
So normally I try to do half an hour to an hour of integration time, but for these wider spectra, because I have to do like multiple parts, yeah, I usually do like about 15 to 20 minutes per individual like spectrum. Otherwise I'm like serving like the source for hours, and then it gets a little bit more tricky, of course.
And do you ever see interference from satellites?
Not at 22.2 gigahertz. I have seen a lot of interference actually at 12.2 gigahertz when doing methanol.
Okay, thank you.
And masers be rotating that you are seeing them pass through our field of view and out? Edward, can that be causing the changes in amplitude?
I am not sure. So from what I've read, actually, in some of the papers, that's actually the masers are found in some sort of like a gas outflow, the central star forming region, or from a proton star. So they're not really rotating, but they are definitely like moving in different directions based on where the gas is flowing.
So they can have directionality to them.
Probably, I'm not sure actually. But I would say like if like a cloud has if you have a maser cloud is somewhat elongated, like it's a bit like asymmetric in shape, then of course it's gonna have like more amplification in the long axis. So it will very likely have some directionality at least. Because it's very unlikely that you would encounter like a perfectly spherical cloud. It's always gonna have some more amplification in some direction because it's just like longer in that direction.
Thank you.
Hey. Okay. Alex, thanks. Good work. Keep that up. Alex, you said you had something to show?
Yes, I do. Let's see. Let me share my screen if I can. See how that works. Is it working? You see my desktop?
Yep.
Okay. So this is going to be less rigorous than some of the others. What I wanted to do, I wanted to show you the processing involved in the H-line 3D software, processing the IF average files and displaying them on the Meridian 2D and 3D plots. And the data is from this Yagi. It's a circular patch feed disk Yagi. This is the student edition. This is the latest version of the student edition where the backbone is a wooden dowel and the spacers are polyethylene. And so what I want to do is to show you how easily we can process a set of data. Up here is the directory of the 299 files, and I want to show you how quickly this software will process and add the process files to the list. So to bring up this software, and this is the H-line 3D processing, and all we need to do is to go find the file set, which is, let's see, MCPY. Hold on. Oh, wait, no, it isn't there. Let's do this again. Hold on. I think I separated it out to make it easy. Now I can't find it. Here it is. So the whole set of files is open, and what you can do is there's drift with this data over a period of time. There's drift. I don't know if it's thermal drift, it's atmospheric transparency, it's sunlight reflecting off the shrubbery, but this is a 2-point correction, MX plus B correction, and you can change these points. And I want to show you the effectiveness of these. The default is 6% over and 90%. And I'm going to process them this way, and I'll label this first one 06 and 90. And I'm going to process the 299 files this way, which only takes a few seconds. Okay. Now I want to change this point over, and I'll show you the difference. Over here, I'm going to change this to 25%. And we'll change the label down here, 25 for low and 90 for high of the percentage of the frequency range. And so we process the files. And if you come up here, we have all of the different files. I'm going to show you what we've got. So come over here, and I'm going to open a file, and it's probably already set on that directory. Come down here and I'll show you what the raw data looks like. And this is the raw data set. And this is the drift over time. This is a 24-hour sample. And the other thing the software will show is the drift. The drift there, and it varies about 0.35 dB over the time range. And this is not amplifier drift. The amplifier, the Solberg LNAs have a drift of only 0.1 dB per 10 degrees C. So this is something else. And some point, I may try to quantify this by putting thermocouples on the antenna on the LNA and trying to see if I can identify what's going on here. But I haven't done that yet. What I want to do then is to show you, hold on, not this. Let's see, open. And I'll show you the corrected data. Let's see. Let's do it with the 6 and 90. And okay, so it has set the 6% point at 0 dB, and over here at 90, it's set it at 0 dB. But this really isn't optimal. This isn't a good choice, but you can see they have all been normalized to this frequency. I'm going to move it over, clear that, and I'm going to open the one where I move the MX plus B point to 25. It looks pretty good. So that's a pretty nice data set. As the background's been corrected, and I'm getting about 1.2 dB above cold sky. And so the data looks pretty good. And so you get a lot of information on if the system is working from the 2D. The 3dB is the frosting, where you can plot this in some interesting 3D modes. So I'm going to open a directory for the 3D plotting. Let's get rid of this. It's open. Let's just plot the one where we know it's corrected properly. Down here. Yeah, how about that? That looks pretty good. Pretty nice set of data. So that's the two sides of the Milky Way being plotted. And you're looking down on that in the Z direction. And then there's other, let's see. Let me see what this looks like. There are lots of other formats that RTOP offers. That one not working? There we go. And you have the ability of rotating this plot. And so there's some pretty nice dramatic ways of viewing the data. I'm not sure that this is scientifically useful, but for a set of beginner software, it's impressive. Gives you a reward for all of the tedious effort of setting up your antenna, recording the data. And here's a high intensity version of that. And so this is A-Slide 3D, and it's fast, and it produces calibrated plots. You can use this 2D to take a look at your data, try different experiments. If you change the length of cable between your antenna and your LNA, you will see the change here. If you scan through the same piece of sky, you will see the improvement in the performance of your system here, because this is calibrated, normalized data. Are there any questions?
All right. Thanks, Alice. Good stuff. Ted.
I am here. I push buttons now. We'll admit. All right. And then we do this. I'm hoping you see that.
Yep.
And this can go like, okay. It's cold outside, so I'm turning back to software. I've decided that Ezra somehow doesn't have enough plots, and somehow it doesn't have enough keywords. So I'm adding a new one here on the right, EasySkyBall, and then comma separated values. That kind of file can go into the the 3D graphing that Alex has just talked about as well. For our review, I gotta go here and then look here. All right. We point an antenna up at the sky and we go away and let it record for 24 hours. It's just parked looking at a particular spot, pointing in the sky. Starting on the right-hand side, it draws its power on the radio sky as from right to left. And we see at one point in the day, it has some more power, and another part of the day, it has some more power. If you go out there and then do that again, but with your antenna at a different elevation above the horizon, you get a slightly different curve. When you put them all together, you start to see a pattern when you plot it on the radio sky to show where the galaxy is. Okay, that's all good review. Each one of those is a line. You can change that data now to different colors instead of bumps, and yellow being a brighter power. That's fine, but you can see it's ragged here. We see squares and sharp edges because we're drawing great big broad bands across the sky with data missing between your data scans. EasySky can also look at that data and interpolate or predict the data between those data scans, and it comes out a little bit smoother once the computer does that for us. This is called an EasySky 400 plot for a name. We can use that in several ways. Just for fun, using the 3D graph plotting, we can now take that plot and project it on a ball out in space. There's the plot. And I hope it's not moving too fast for Zoom for you to catch up with. I see a moving ball spinning around. It is a ball in space, and the camera is flying around it, taking pictures towards the center. We can see the strong part of the galaxy there, and then 180 degrees from it is the other weaker side of the galaxy. I just thought that was fun, but of course, this doesn't represent reality. The Earth is inside that ball and where we are with the sun. So we really want to be inside looking out. All right, let's do that. Let's plot it on the ball again, but this time sit inside the ball looking out. And this is more realistic to real life. Here we are sitting on the Earth, and the Earth rotates to the east, and we see the sky rising in the east and setting in the west. This is pretty much what our telescope is looking at as the Earth rotates. So I thought that was a little more helpful. I have some enhancements to do to this as well, but it's a nice start. We could also take a look at that very same data and plot it in galactic coordinates shown here. That's why we see the bright spot of all the data as a plane going across the galactic plane along 0. There's some places where I don't have data. In the top left is too close to Polaris, and I couldn't get my antenna up that far north. And on the right is a part of the sky I can't see because the Earth is in the way. If we take this EasySky 500 plot and project it on a ball, I thought it was interesting, but this time it's a little different. Where all those bright yellow powers are, I made the radius a little bit bigger. So now the radio bumps are real bumps sticking out from the sphere. There's parts of the sky that I don't have data, and so I represent them as the minimum color. It's an idea looking for a cause. I'm not sure this is great, but it's fun, and maybe it will attract attention. A lot of this movie creation with 3D is described in the latest journal with my article all about how to use these things. And then, of course, the software for Ezra is on its standard webpage with videos, me talking and trying to explain it, and more info in all kinds of ways. You're welcome to email me and we can chat about all kinds of things. Any questions at that point?
Ted, can you please show again that slide where you had the galactic coordinates?
How about this one?
Yeah, that one. Just trying to understand so the bottom is the galactic longitude.
Yes. And galactic latitude on the left. The galactic plane is along 0.
Yeah,
and
that's
looking
right.
out into space.
So I'm just trying to figure out, so your 0 should be towards the galactic center, right?
In the middle of the picture, correct.
Yeah. What puzzles me is the gap at around 150 to, let's say, 120, because that should be visible from your location.
Yes, it should be, if I could tilt my antenna up that way. This is the great big 16-foot antenna, and I'm a little scared about leaning it over backwards. And so I can't get up to the
So it's a limitation of your antenna, and the other part is.
Yes, I can get more data this way, and I just haven't gone to the point. The Earth is in the way for this lower part.
Okay. Yep. Thanks.
Very good. Back to Rich.
All right. Great work. Good stuff. Okay. We'll see. Let's start going down the list. Henry.
Hello?
I see you and I hear you.
Okay, that's okay. Yeah, good afternoon, good evening. You've seen my name. I'm currently located near Prague, and I also reside in Paris, but in Prague I have my observatory. On the 11th of November, I sent an introductory email describing what I'm using for equipment and proposing some information or more in-depth presentation if some of the topics were to interest you. But of course, I'm still a beginner. There's for those topics for you all are very common. But I guess more and more you will maybe see me. I will try to attend the meetings live, and if I think I can be useful, I will make suggestion or ask a question also for me to understand. So that's the presentation.
Oh, that's great. We'd love to see any observations that you make with your optical scope too. It'd be fun.
Okay.
And I think if you look at this crowd in general, a lot of technical people here and a lot less astronomy knowledge.
Yeah.
So anything you can add to astronomy in general, masers, hydrogen clouds, anything like that would be wonderful.
But so far there are two things I've noticed. One is that you do everything except radio astronomy. That means you have to do mechanics, electrical mechanics, construction. So you have to do a lot of peripheral work if you want to do radio astronomy. And the other thing also I found is the ratio of 99% perspiration for 1% satisfaction.
Once it gets set up, it goes pretty easy, Henry. So it's a lot of beginning, it's a lot of tweaking, it's a lot of adjusting, but once it's all together, it works. And so you sit back and just let the sky go by and take data.
I'm starting to have more and more understanding now what's happening, and that's what started me to pop my head out of the shell.
All right. Glad to have you here. Thank you.
Thank you very much to all.
Don, you got anything else going on?
Oh, not really. Some deity or other decided to make a New Year's resolution. So we're now having snow. And it's back to software. I'm struggling with something called Node-RED and MQTT, trying to get organized to get the antenna going.
Okay. All right. Thank you. Listen, Al F. NB0YZ.
Can you hear me?
I can.
Oh, great. Glad to join you guys. I'm new to this group. I just joined in November. I just retired on December 31st after a 38-year career as a medical physicist, and I've had a lifelong interest in radio astronomy and optical astronomy, but mostly radio astronomy. And so I'm a novice. I'm just getting involved in this. I'm pretty excited about it. And so glad to meet everybody, and I'd like to join in the future. The only thing I've accomplished so far is I built a 21 centimeter horn with a sawbird and a RTL receiver, and it has not even looked at the sky yet. So that's how new I am at it.
Okay, great. There's a lot of, are you on the listserv yet?
I do not think that I am.
If we get you on that, then you could start showing your stuff off. It's almost like a 24-hour help desk with all these guys on there all the time. And you can show you what you got. You can ask questions. You could really tune up your system with the list. With that.
Great. I appreciate it. I think now that I just retired, I'm going to have a little more time for radio astronomy and for ham radio. So looking forward to all that.
All right. Glad to have you on board.
Thank you.
All right. Dennis Hufnagel.
Well, I don't really have anything to add. I'm really enjoying this session, though, and anticipating getting more done. So thank you, Rich. Send it back.
All right. Thanks. Detlef.
Yeah. Hello, everybody. It's Detlef. I do some investigation for interferometry. I try to do it. As the first thing, maybe I can share a few things. Sorry, one moment. I think here. Sorry, I think I'd want to make some evaluation at interferometry. I find a Facebook page, and one, I think Jan Hennings makes some shows a few ways to make interferometry. I find a book, an old book, which helps me too, and so I think I start a bit to work on it. I have two patch Yagi antennas. Due to our small terrace roof, I could use the difference distance between two antennas is only about 4 meters, so I couldn't take bigger antennas. I have two LNAs with a bandpass filter, and I take a mixer for the switch, 180-degree switch, and I think a combiner, filter, and the amplifier, and a lock detector. And after this, I take a balance demodulator. This is this in microchip from analog device. I think it's to, what could I say, to match amplifiers and a switcher, a low pass filter with, I think, 2 seconds integration time, an ID wandler, ID converter, and a Raspberry Pi for the controlling, for the measurement, and I think a rectangle generator, which makes a 200 hertz signal to switch between the two phases. I think it works. So one moment. Could you see my whole picture? Sorry. Yeah. Okay. I think this is a signal after the power detector. Many disturbance on it. And after the correlator. I think this signal is really good. And if you make a small area, you look to a small area, you find something like a flinting pattern. It works very well. Only 2 or 3 meters distance between the two antennas. And okay, if you take only a small area, I think it looks very nice. Distance between the antennas is 2.5 meter. And if you make some Fourier transformation to the signal, you get a peak between, I think, 11. I think it can, this is a German value of Raumfrequenz. It's the distance divided by the wavelength. And so I think I find the 2.5 meter again. And one experiment with 3.3 meter. It works very well too. And the last day I tried to use 3.5 meter. I think something is nearly really wrong, or maybe we have snow. I don't know if there's any problem. So it's only the first experience. And now I look for the next days. Okay, thanks.
Detlef, what were you looking at? Was this the sun?
Oops, I don't know. I think the Milky Way.
No,
my
you
opinion.
only, no, it wouldn't be the Milky Way. It has to
Okay.
be, it has to be a point source if you see fringes.
Okay.
What you
Okay,
would
in this case, it must be the sun, I think, yes. I'm not sure. I don't know.
What was the duration when the fringes occurred?
I think
How long?
LR is about 18 hours.
Yeah, okay. It's
Mm.
most likely that you, the strongest signal that you get with a small antenna is the sun. So essentially
Okay.
what you would see is
Okay.
the sun passing through.
Mhm.
What you would also see is that the fringe frequency will vary over the day. So if you observe it for a long period,
Mhm.
there should be a change depending on where the sun is. The fringe frequency will be the shortest when the sun is highest, if your antenna is looking south.
Oh,
I'm not
okay.
sure.
So, yeah, I think this is the first steps for me. Thanks very much. Okay, that's all.
All right, great. And I think
Sorry, Detlef, I wonder if I could ask a favor of you. Would it
Yes.
be possible? Don't say yes, just think about it. I wondered if you obviously had a PowerPoint presentation there, and I wondered if there's
Yeah.
any chance I could have a look at it. If you feel up to doing it, I've put my email address in the chat. But
Okay.
only,
Okay,
only if you're happy to do.
I send you my email too. Okay, thanks.
great. And I think a lot of the observers use stellarium to point their antennas for the sun and for any other point source. So you might get a free copy of stellarium and then figure out where the sun's going to be on stellarium at your elevation angle, and then
Okay.
you'll be able to figure out exact times and everything the sun's going by.
Thanks.
That'll help a lot, I think. All right.
Okay.
Great stuff. Good start. We'll see. Tom Fulton, our brand new member, California.
Yes, sir. Good afternoon. Hello, everyone. Happy New Year. So, yes, I am based in San Jose, not too far from the Stanford dish. I guess that would give you an idea of generally where I'm at. I'm coming at this from a slightly, I guess, pretty drastically different angle. I'm actually a consultant specializing in 802.11 and using SDR, basically cybersecurity assessments for customers worldwide. I work for a large company called Lumen Technologies. So I've evolved a passion from the 802.11 analysis. In other words, looking for ways to essentially protect my customers from exploitation via Wi-Fi, Bluetooth, BLE, and so forth, to playing with the SDR Sharp, GNU Radio, and then I've evolved that into the Inmarsat. I've got my Inmarsat Amazon antenna in the backyard, and so just I'm reaching out and looking into other areas that are similar. I don't come from radio astronomy. I come from a cybersecurity assessment background and currently am a consultant. I go on site and I do assessments. So yeah, a little different angle, but very much interested in everything you're all discussing. I was particularly interested in what Dr. Andrew Thornett was discussing. But at any rate, thank you for allowing me to join, and I would very much to keep attending on these monthly meetings. So thank you very much.
I'm more than welcome, and we got 2 other ones this month, and get on the listserv and ask questions. And yeah, you're gonna learn a lot about receiving technology and low power processing and stuff. So this will help. Okay, let's see, Preston.
Hello, everyone. I just have a question today, and that is, I haven't looked in a few days, but when will the Western Conference registration be available?
We're working on that. We just Ken Redcap is finalizing the dollar value, and I think it's going to be still $15 for online, and it's in the range of $50 for in person. That'll take care of lunches and various other things. So we're still working on that. I'm still trying to get my daughter to come up with a good logo for a shirt. I can buy some shirts or something. And it's still working. So hopefully the next 2 weeks, you'll have a store where you can go on the store and register. And we're actually, Chip's actually working with Ken to make that happen.
Okay. Thank you.
Well, thank you. Let's see, Bob Strickland.
Yeah, hello everyone. Good discussion today. I really enjoyed it. Looking forward to the new year myself, hoping to get more accomplished in this area. On the Meteor stuff that was mentioned earlier, Meteor cameras are picking up about 200 meteors a night right now, so we're in a pretty prolific time for meteors, and that stuff does work for me 24 hours, like Alex was mentioning. And I'm also picking up my magnetic monitoring of the Earth's field variations due to the sun's activity. But anyway, I'm studying different ideas on how to move my dish around too, looking for the best solution on that. And so lots to keep me busy here. That's it for me. Back to you, Rich.
Okay. Helen.
Oh, Happy New Year to all. We're still trying to get over our virus, so I'm just in listening mode today, trying to learn as much as I can. And I wish you all a very wonderful New Year. Thank you.
Thanks. Well, get well. All right. David, I think you're David Kunzman. You're the last one.
Oh, yeah. I'm just relatively new. I've been thinking about setting up a SuperSID. Just have to order it. And just had a question about the SuperSID. Is anything done with that data that's collected by the instrument?
Yes. It's just saying the feedback here. It is collected by the Stanford website. All the SuperSID output. If you got your computer with SuperSID tied to the internet, then it'll actually transmit once every night and populate the Stanford website. And if you look at, we'll find the Stanford website, but look under SuperSID Stanford, and it'll give you you can see all the worldwide SuperSIDs that are out there. And you can see what they're collecting at any point in time.
I know they had a big flood though, and so they're trying to create the computer systems. So there may be a temporary outage. Is that true? Rick?
Yeah, I heard the same thing. I agree.
But
Wow.
they're trying to fix it, which is good.
Yeah. Okay. But yeah, and it's a thing. I had mine running for about 10 years, and it's the most reliable radio telescope I ever had. See all the flares. You can even see eclipses if they come over you. Yeah, it's a good way to start.
And can the instrument be located inside your house, or does it have to be outside?
The antenna, I've seen some people have the antenna up high in the house, but most of them have it outside. It's a 5x5 rectangle square with a wire wrap around it is the antenna. Now the inside stuff, yeah, it's just that's easily inside right next to your computer with a cable. So it's just question where you're going to put the antenna. And some people do have it in their house.
And just one more thing. 2 months ago on your meeting, I listened to at the beginning of the November meeting, you were talking about possibilities of professional amateur collaboration. Do you remember that at all?
Sure.
Oh, and you were mentioning like possible surveys and then amateurs putting their scopes on pulsars and leaving them for a while. The professional amateur collaboration, would that be possible with a scope in a box or a smaller radio antenna?
We haven't, there is a crowdsourcing, or what is it? The citizen science pulsar group is looking for amateurs to go review pulsar data. And that was part of that. There's other ones that do galaxies and things like that. To use our antennas for professional, and Wolfgang's the closest one to calibrated professional data with his big dish. It really has to be calibrated. The scope in the box stuff is really not calibrated. It's the ability to see the stuff and then just to start improving on it. But yeah, you probably won't go, well, professionals probably won't jump in and try to get your data from that. Anybody else had experience in professional collaboration?
Maybe just one comment. If you look at small dishes, probably the best opportunity to do something as an amateur, which could be of interest to the scientific community, is actually on the maser side. The reason being that these are highly variable, as we have just discussed. It has been nicely demonstrated that it can be done with smaller dishes. If you do a long-term project on observing a few strong masers, hydrogen masers with a small dish, that might be a possibility. I haven't talked to anybody about it. There's some maser people that I know, but I haven't talked about them, how they would be interested. As far as other things are concerned, pulsars, etc., the small dishes are just not sensitive enough to do something that it would be of interest. So if you really want to go into that, maybe actually the water maser might be something.
Now, another thing that I was experimenting with is the VLA, all the big interferometry systems out there have historical data files, which you can go, after a year, they make them public, and you can go in and process them and try to come up with scientific data with it. Okay. And then that is a good way for amateurs to go use professionally observed data. And it's calibrated, and you have to calibrate, you have to do all that stuff. But that's a good way to do that. And then you can actually, if you find something, you can write scientific paper against it, even though you weren't the original collector on it. So and there's a couple YouTube videos on that. about how to process what those look like. That's another way to start. You don't need much computing power. You do it from home, things like that.
Yeah. And that would be using like the NRAO CASA software to.
Absolutely.
Yeah.
And
Okay.
do their tutorials and you'll get the idea of how that works.
Okay. I'll look
right.
into the laser stuff possibly, and then look into the historical data. So thank you very much for answering my questions.
Yeah. Yeah. Welcome back. Anytime. All right. I missed anybody have anything else? All right. See you guys in 2 weeks. Thanks very much.
Thanks. Goodbye.
Bye.